In the previous video, we showed how to build basic circuits with transistors. The circuits we built were NOT, NAND, and NOR. From these, we can build the more common circuits AND and OR by simply knotting the output of a NAND or knotting the output of a NOR. Question is, do we need all three circuits? NOT, NAND, and NOR, or alternatively, NOT, and OR? The answer is no. We can build everything with either a NAND gates or with NOR gates. Now, what you're looking at on the screen is a display of Logisim. It's running under Windows at the moment, which virtual Windows in my Linux system. Logisim is available for free download. It's an open source GPL product, and it's quite handy to build small circuits and see how they work. What I've done here on the screen is built a small circuit. This is a NAND gate. You can tell it's an AND with the little circle. Means that's the knotting of the output of the AND. Now, normally an AND has two inputs. You'll see Logisim allows for more inputs. So if I had three inputs on an AND, all three would have to be 1 for the result to be 1. Any combination that involved zeros, the output would be 0. It allows for extended versions of these circuits. But anyway, we have two inputs, and the two inputs are shorted together. So there's really one input, and it's a 0. And you can see the 0 produces a green going in here. On the other side, however, dark green indicating it's 0. On the other side, the output side, it comes out as a bright green, which the probe or the pin shows as 1. So if I have a 0 going in, I get a 1 going out. Now in Logisim, we can toggle these. I clicked up in the upper left-hand corner there, which allows me to toggle. If I click this, it switches it to a 1, and the output here is a 0. So yes, what I've got here is a NOT. How is the NOT built? It's built with a NAND. Very simple. Okay, the next question is, can I build a NOT with a NOR? Yes. Well, first of all, we have to get a NOR, and there's a NOR gate over here, and I drag it over to the screen. Try to line it up a little bit. And again, it's got multiple inputs. We don't worry about them. We want to put a line coming out. We want an output pin, which I'll put right here. And we want to give it a label. We'll call it D. And it's seeing errors at the moment. We have two inputs to the NOR. There will be one of them. And here is the other, whoops, which I'm just tapping on them and hitting the left button on my mouse. Okay, there's the basic input, whoops, and we can just drag lines here, and we're going to put an input pin on it right here. And you see the circuit kind of starts working there now. So this is a NOR gate for whose inputs have been joined together. Now similarly, I go back up here to the toggle, and you can see when I toggle it from 0 to 1, the output is 0 and 1, flips back and forth. So this is a NOT as well. So with a NOR or with a NAND, I can create a NOT. Next question is, can I create an AND using just NANDs? Well, yes, the answer is I can. So I pull out a NAND gate here. Oh, I didn't give any input name for up there. That's all right. Doesn't hurt. I'm going to need two NAND gates, so I'll pull another one over here. Drawing is not my special talent here. I am going to gang two of the inputs here. I can't go more than one at a time. And so the output of the first NAND becomes the input of the second NAND. And I'll pull this out someplace here. I'll add a pin on at the end. Take it? No, it didn't follow me. All right. There's an output, which again, I can give it a label. Let's call it E. Doesn't really matter. I go back over here, and what I will do here is I'll have, of course, we are talking building an AND, so we've got to actually have two inputs. And we'll take an input here and stick it on there. And we'll put an input here. It's going to be a little crowded, but it'll work. So I got two inputs going into the NAND gate. the output of that is joined together, basically is knotting it. So what we've got here is we've got a NAND, and the output of the NAND is knotted. So we should get if I oops, get my toggle thing up there, had the wrong symbol. If I put a 1, still a 0. If I put a 1, however, 1 and 1 is 1. That is, this circuit is an AND gate. If either one of them is 0 or if they're both 0, the output is 0. So this is an AND gate built from 2 NAND gates. Next question is, can we build an AND from just NORs? And yes, although we're going to need 3 of them. NANDs are preferred because things get simpler with NANDs as a general rule. But nonetheless, we pull a NOR gate, and we'll put this one out here. Whoops. Try to be semi-neat. We'll need two more. And where is it? There it is. And I drag it over here. There'll be one, and we will pull another one right here. Now, in the case, again, it can have multiple inputs, but we're not worried about them. Oops. We did this really neat. Everything would line up. There was a grid, of course, that you can use to line it up. And we put some input. Basically, what we're building right here is 2 knots. All right. And now the output of these guys goes into the other. All right, and we'll pull the output here, and we'll put a receiving pin over here, and there we are. Now those are NORs. Now you can sit down and do the truth table on this. It's not that hard. These effectively are 2 knots, because the input's gang, just like up here, this was a knot. These are knots, and this is a NOR, and the inputs to the NOR, when you do the truth table, you'll find out it is, in fact, an AND. So we'll just prove that here. Whoops, I have to get my toggle thing. The finger is the one that does it. Still 0, but when they both go to 1, you see the output, in fact, is 1. If either one of them is 0, or if they're both 0, the output is 0. It's obviously an AND. So we have built an AND circuit from just NORs. So now what have we got so far? We've got NOTs built from either NANDs or NORs. We've got ANDs built from either NANDs or NORs. And so the third one we need is an OR built from either one. So we'll start off with the NAND form. We're going to need 3 NAND gates. And we'll pull another NAND gate over here, trying to line them up a little bit. And we'll need one more NAND gate. How about right here? Now, the outputs of these 2 we will make to be the inputs of these guys. Again, there's multiple. Whoops. This is a very handy tool. By the way, you can actually go up here where it says project. It'll go in there and build you the truth tables. I've got so much on the screen right now, the truth tables would be horribly confused. But I should have done it on any one of these, and you would have seen the actual truth tables for the labeled input and output. You do have to label the input and output so it'll tell you what we're talking about when it builds the truth table. Okay, the final output here. We use the second one. Notice I'm using the second one. Well, it didn't take it. Okay. Okay, it says the circuit's got errors in it. Obviously it does. And so our input here, these are essentially going to be knots. Well, not essentially, they are knots. And we'll do the same down here. And bingo, bingo, input, 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 happy circuit. So we are building an OR. The question is, have we built an OR? Well, let's try it out the empirical way. If both these are 0, the output should be 0, which is what we've got. If either one or both of these are 1, the output should be 1. So if I click this, bingo, goes to 1. If I click this, goes to 1, or stays 1. If I click this and that one's just, yeah, those are all your alternatives. The inputs are either zeros, in which case you get a 0. Any combination of 1s, you get a 1. This is an OR. All right, the next thing is, can we build, and built with NANDs, I might add, can we build an OR using just NORs? And yeah, that's relatively easy. I just pull an OR gate here, and I pull another one over here. Whoops, there we go. And the output, essentially what we're going to do here is just have a not the output. We're going to not the output of the NOR, which this is the somewhat obvious one. And we will take an output pin over there. We'll plug it in over here, and we will take. Whoops, I'm premature here. I started to bring. All right, now let's delete it. Right click, delete it. I wasn't ready for it. This will be an input, and this will be an input. There's the two inputs. Now I've got the input pins here, and I've got another input pin over here, and ready to go. So this is the easy one, because all we're doing is knotting the output of a NOR, which of course makes it an OR. Any combination of zeros or ones produces a 1. If they're both zeros, the output is 0. So what have we proven here? That if all we've got is NANDs, we can still build anything. If all we've got is NORs, we can still build anything. Now, in most applications, from a fabrication point of view, NAND gates are supposedly easier to make, so a lot of the technology, I am told, is built based on NAND gates. But either way, so in fact, we only needed one circuit. We needed either a NAND or a NOR, and with those we can go anywhere we want to.